Dark matter. For a body orbiting a mass, the centripetal force needed to maintain the circular motion comes from the gravitational attraction of the entire mass contained within the circle of that orbit. So we can say that the force F is equal to the mass of the orbiting object multiplied by the gravitational field strength, and this provides the centripetal force mv squared over r, where v is the speed of the orbiting object and r its distance from the centre of mass. This is provided by the gravitational attraction given by the gravitational constant multiplied by the product of the mass of the orbiting object, the mass contained within the circle of the orbit, over r squared. We can simplify that to get this term, and then rearrange to get the speed is equal to root gm over r. This shows that so long as the mass at the centre, capital M, is constant, as the separation r increases, the speed v reduces. This is what we see in the solar system, where as we go out from the sun, the planets move more slowly. Within the solar system, virtually the whole of the mass is contained within the sun. When it became possible to measure the rotation speed of galaxies, it was found that the orbital speed of the stars around the centre of mass of the galaxy was more or less constant as we moved out. This suggested that as the speed is equal to root gm over r, the mass m must increase in proportion to the radius r increasing. Previously it had been thought that most of the mass was concentrated at the centre of the galaxy, where the stars are more densely packed. These new findings showed that there was around 10 times the mass previously thought to exist within the universe. 90% of the mass of the universe was not visible, and so it was called dark matter. If spiral galaxies did not contain dark matter, the stars near the centre would be rotating faster than the outer stars, and the galaxy would in effect wind itself up. However, because of the dark matter, the whole galaxy does maintain its distinctive spiral shape.